Okay, thank you for being here. I hope we can see each other the next year in a better situation. Well, I'm so excited to be here, and I really hope you enjoy this talk. Okay, today I'm gonna talk about bypass of rules of web application firewalls and intrusion prevention systems. I'll do an overview of all researches I made from 2017 and 2020 on this topic. Why this talk? I would like to use the words from the Stephen Gates book, Modern Defense in Depth, that say the number of organizations that have invested in hardware-based web application firewalls to protect their public-facing web applications is enormous. However, many organizations have deployed their web application firewall out of band in monitor mode or have never adequately tuned the WAF rules to their fullest capabilities. And I couldn't have said it better myself, and I think this is true, especially for many WAF as a service. During this talk, we will see techniques to bypass rules and filters to exploit some vulnerabilities like remote command execution in Bash, remote code execution in PHP, and cross-site scripting. Before start, I quickly introduce myself. My name is Andrea Menin. You can find me on the internet as the middle. I work in the info space, in the InfoSec space by about 15 years. I'm part of the OWASP Mod Security Core Rules team. I'm the founder of Reverse Security, that is an Italian InfoSec community. And I'm one of the admins and writers at SecJuice. And if you want to keep in touch, please follow me on Twitter, on my brand new Twitter account, because my old one was suspended. I'm the bad guy for Twitter. And in almost all the slides I will show you, you will see a QR code on the top right corner. And that code forwards you to an article in which you can go deep on the topic we will see together. Okay, just a quick introduction on what a web application firewall is. All bypass I will show you are a proof of concept tested against famous and widely used web application firewall as a service. Web app firewall inspects all HTTP requests and HTTP response at layer 7. And thanks to a list of rules, typically regular expression-based rules, it can block malicious traffic or attacks. It could be used on-prem as a service or in cloud or hybrid mode. And most companies use web application firewall for doing virtual patching. That is a magic word that means patching the bug without touching the source code. And I know what you are thinking, that this is a bad way to fix a problem. And when you do a virtual patching, the vulnerability is still there. And I absolutely agree with you, it's a bad word. But there are many situations in which having something that gives you time to patch or time to upgrade your web app, or makes you able to apply a patch when touching the source code is not an option. In my personal opinion, it's a good choice to reduce the risk and protect better your assets. So let's say that, let's say that you have a website where user can upload their kitten photos, for example, and write stories about them. And your website is hosted by kittenhostingcompany.com. And to protect it, you decide to put a web application firewall in front of it. So all users that want to connect to your website must pass through your web application firewall and can't connect directly to the origin due to net filter policy, something like IP tables rules, for example. And then there's you-know-who that try to exploit a vulnerability on your website to remove all kitten photos and replace them with snake photos. Okay, all his attempts are blocked by web application firewall thanks to a list of rules and regular expressions. And all his HTTP requests will never reach your website. This is more or less how a web application firewall works, a web application firewall as a service works. Now, the question is, can you-know-who somehow bypass your web application firewall to exploit the vulnerability on your website and replace all your user and kitten photos? I mean, if your WAF runs a weak rule set, maybe the answer is yes. Yes, you can. And let's see how. Okay, let's say that you found a remote command execution vulnerability, but the web application firewall blocks your exploit attempts due to regular expression-based filter that blocks a well-known command, for example, bin cat, or well-known file name, for example, etc password. And trust me, there's a lot of web application firewall rules that do it. You can bypass these rules by using, for example, bash globbing patterns. Bash standard wildcards, or AKA globbing patterns, are used by various command line utilities to work with multiple files. And if you want more information about globbing patterns, you can type man7glob on your terminal. So you can bypass this kind of rules by using globbing patterns, replacing some characters with a question mark, for example, or replacing almost all characters with question marks. Or you can even use character range syntax as shown in this example. You can do really crazy things with character range syntax. This is a proof of concept that I made using a WAF as a service that, as you can see, is blocking my attempt to get the etc password content. This is the payload I try to inject. I try to inject bin cat etc password to get the etc password content. And the WAF reply with a response status 403 forbidden with a landing page that say access denied, as you can see here. It was really easy to bypass it by replacing almost all characters of my payload with a question mark, as you can see here. And as you can see, I managed to get the etc password content. So bin cat and etc password, I haven't sent the etc password string anywhere in the HTTP request. So I managed to bypass this rule. Another way to bypass this same kind of rules is to use string concatenation and escape sequences. In many programming languages, we can concatenate strings by using, for example, the plus operator. And for example, hello plus word has the value hello world. In other languages, we have different operators for example, the dot in Perl and PHP, or the double dot in Lua, etc. And in a few languages and scripting languages, there is something called string literal concatenation. meaning that adjacent string literals are concatenated without any operator. You can use, you don't have to put an operator to concatenate. For example, hello world, hello and word has the value hello world. And this works not only for printf and echo commands, but it works for the whole bash syntax. So let's say again that web application firewall is blocking your exploit attempt because a regular expression intercepts a command, for example, being cat, or a common file path inside your request, for example, let's see password. You can easily bypass it by using string concatenation like this. This is an example on my terminal. And you can even use escape sequences like this example. Okay, in this proof of concept, I have injected the payload using string concatenation, and I was able to bypass these WAF rules and get the etc password content, as you can see here. And this is the same injection, but using escape sequences. And here is the etc password content. Another bypass technique exploiting a remote command execution is to use an initialized variable. By default, bash treats an initialized variable like Perl does, for example. They are basically blank string. And the problem is that the problem is not a problem, is the way it works actually. Is that it's even possible to execute commands concatenated with initialized variables, and they can be used inside arguments too. So being an initialized variable, cat initialized variable is translated by bash variable substitution to a blank string. And it becomes bean empty string, cat empty string, etc. And it works, as you can see in my example on my terminal. And in this screenshot, you can see a famous web application firewall as a service that is blocking my exploit attempts. I don't know if you can read the highlighted injection on the address bar. I'm trying to inject cat etc password on the host argument on the query string. And by exploiting the same remote command execution on the same web application firewall, I managed to receive a reverse shell on the bottom left by injecting the payload on the top right using an initialized variable. As you can see on the top right, I use netcat, initialized variable, bean, initialized variable, bash, initialized variable, etc. And I get the reverse shell on the bottom left. This is not the only syntax you can use, because you can even use brace, for example, or command substitution, or even complete the command using echo inside command substitution. Okay, let's talk about PHP. The following two are my favorite technique at all. Let's say that you discover a remote code execution inside a PHP web application, but web application firewall blocks your request if it contains PHP function name inside the HTTP request, such as system, pass-through, exec, eval, and trust me, many web application firewall does it. You can bypass it by using together two things: PHP escape sequences and PHP variable function. PHP escape sequences basically makes you able to specify a string by using a sequence of characters in octal notation, for example, or sequence of characters in hexadecimal notation, or sequence of Unicode code point. And PHP variable function makes you able to call a PHP function by using a string, as shown in this example. You can even assign a function name as a string to a variable, and then using this variable to call the function as shown in the last line. So by using both techniques, you can call, for example, the system function without sending the string system anywhere inside the HTTP request. You can convert each character of this string system into hexadecimal escape sequences, and each sequence is converted back by PHP as in this example, S, Y, S, T, E, M, etc. In this proof of concept, I managed to bypass the web application firewall using both techniques shown before. As you can see in the top right, the payload, I used the escape sequences in order to don't send the system string on inside the HTTP request, and I'm trying to execute cat etc password, putting an initialized variable after etc $u, for example. And as you can see, I managed to get the etc password content. Okay, but what if a web application firewall blocks the double quote character and single quote character? You don't worry, because PHP makes you able to specify a string even without using single or double quote. I know this is crazy, but you can do it. You can even use the concatenation without quotes, and you can use comment too inside the concatenated strings, as you can see in this example. And here you can see that I managed to bypass the web application firewall by using these techniques without using double quotes or single quotes in the payload on the top right. And I get the wmi command output on the response body on the bottom left. Okay, this is an interesting one, and a rule bypass by abusing the PHP query string parser. As you might know, PHP converts query string in the URL or inside the body. For example, when you send an HTTP request with content type application www formal and code to an associative array inside the, for example, the global variable $get or $post. For example, the query string foo equals bar becomes an associative array in which foo is the key and bar is the value. Okay. In order to do it, PHP needs to convert all arguments into argument name into a valid variable name. So when the query string is parsed, PHP does two main things. It removes leading white space and converts some character to underscore. For example, the query string, the argument name foo underscore bar, it's the foo underscore bar is the key of the associative array inside the global $get variable. But if you put a white space before foo underscore bar, PHP remove it, and your argument name becomes the same variable name. It becomes foo underscore bar inside the global variable name $get. If you put a white space between foo bar replacing the underscore, PHP converts your white space to an underscore, so it becomes the same variable name, foo underscore bar, inside the associative array $get. Even if you use a left square bracket, if you replace the underscore with a left square bracket, PHP converts your left square bracket to an underscore again. So it's again the same variable name, foo underscore bar, inside the get global variable. You know, this is not really well documented in PHP documentation. So I created a script that loops through all characters in the ASCII tables to find all possible combination that PHP converts always to the same variable name. And this is my script. And as you can see, you can use white space or plus character at the beginning of the argument name. You can replace the underscore with a white space, with a plus character, with a dot, or with a left square bracket. And finally, you can use a null character at the end of the argument name. In all these cases, PHP converts the argument name to the same variable name, foo underscore bar. And you can exploit this, you can use this functionality, this parsing, to bypass rules, obviously. And this is a suricata rule by Positive Technology. And for those of you who don't know it, suricata is an open source IDS IPS. And this rule now is fixed. They are very quickly on fixing it. Was created to prevent and block the Drupal add-on to exploits. And as you can see in the highlighted line, the rule looks inside the request body for string like ss underscore callback, pre underscore render, post underscore render, or lazy underscore builder, etc. And it was really easy to bypass it, as we have seen before, by replacing the underscore character to the left square bracket character inside the argument name, and exploit the remote code execution on Drupal. As you can see, I have replaced the underscore on the argument post render with our left square bracket, and PHP converted back to an underscore. So I bypassed I managed to bypass the IPS rule and exploit the remote code execution on Drupal. Okay, let's talk about cross-site scripting. Your target seems to be vulnerable to cross-site scripting, but all your attempts to exploit it are blocked by filters or input validation or WAF rules. And let's see how to bypass them by using script global variable. As I said before, many filters try to intercept the injection of JavaScript code by blocking a list of bad words not allowed inside a request. For example, alert, for example, document cookie, or when you use space between objects, or when you use comments between objects, and so on. And in this case, JavaScript global variable could be used to bypass this kind of rule. And we have got many ways to access the document.cookie from the Windows global variable or the self global object. For example, something like selecting the cookie object inside the document object inside the global window object will not be blocked by a weak filter. And here I have put this table with 3 examples. The first example is what I said before, selecting cookie, inside the document object, and select the document object inside the window object. Or you can call the alert function from the window object, and you obviously you can use command 2 in order to bypass a weak filter. Okay, this is an example on my browser using this kind of syntax. Okay, I don't know how many of you are penetration testers, but it often happens to me to see customers that patch their cross-site scripting vulnerable code by removing some character from the user input. I don't know if this happened to you too, but I really see often this kind of approach, and often developers use encoding function as a quick and dirty way to sanitize untrusted user input. For example, converting special characters to HTML entities. And it may appear a good injection killer to convert characters such as single quote, double quote, semicolon, etc., to their respective HTML entity codes. But in the JavaScript context, it isn't always a good way to prevent stored or reflected cross-site scripting. As you can see here, my payload, I try to inject a payload using semicolon, but the web application remove it. And in the example here, you can see that the web application removed the semicolon from my payload, leading to a syntax error. It's possible to exploit cross-site scripting vulnerability in this specific JavaScript context without using any semicolon character by using JavaScript arithmetic operators. Not only in JavaScript arithmetic operators, you can use bitwise operators, logical and/or operators, etc. As you can see, I changed the payload that I used before using the subtraction operator instead of a semicolon. And this makes the browser to execute first all function and then do the arithmetic operator, as you can see in this screenshot. Okay, subtraction is obviously is not the only operator you can use. Indeed, you can use you can bypass this weak input sanitization using bitwise or bitwise XOR, comma, division, multiplication, reminder, subtraction, obviously, in operator, and so on. Okay, I've talked about how to bypass weak filters, validation, and of the user input and web application firewall rules. But are all web application firewall weak, as we have seen before? Talking about web application firewall bypass, usually when I publish a bypass technique, there's always someone who comments, okay, so all WAF are useless. Okay, they don't really protect a web application. Are there really people that use eval inside their code? Something like that. In my opinion, we absolutely need to stop treating web application firewalls as a specialized intrusion prevention system for the HTTP protocol. A WAF is not a specialized IPS for the HTTP protocol. A web application firewall has or should have many other use cases like application security monitoring, policy enforcement, bad bot detection, denial of service mitigation, JavaScript challenge, and so on. I mean, I think that it's not all about the rules or the rules that you use. Talking about rules, that obviously the rules that you use is the game changer. If you use a weak rule set to prevent as much false positive as possible, you are not doing a great job, in my opinion, to protect your web applications. I spent many years working on web application firewalls and mod security. Mod security is an open source web application firewall widely used by many vendors and companies to protect their application. And mod security is the engine and lets you able to create sec rules. And there are some public rules that you can use with mod security and working with it. And talking about rule set, I never found a rule set more effective than the OWASP core rule set for many reasons. The OWASP mod security core rule set is an open source rule set for mod security, and it's an active project and widely used. It protects from generic attacks and not only for specific exploit or vulnerabilities. It has very few false positives, and it could work in a self-contained mode or anomaly score mode. Self-contained mode means that you can block the requests once it hits the first rule, and this is how most web application firewall works. Or it can work in anomaly score mode, which means that a request goes through all rules and each rule assigns a score on it. If the score reaches a configured threshold, you can block the request or you can create an alert or something like that. And the OWASP core rule set has 4 different paranoia levels. And I think one of the main functionalities of the OWASP core rule set for me is that you can configure your whole application or some area of your application using 4 different paranoia levels. Basically, each level adds stricter rules. The default level is paranoia level 1, and the paranoia level 1 is designed to have near 0 false positives. And the highest level of the paranoia is the paranoia level 4. So you can start with the first level, and you can even check other levels rules without blocking any request to see if and how many false positives you have in higher paranoia levels. And you can tune the rule set in order to increase step by step the paranoia level for your web application. And at OWASP core rule set, we constantly work in order to mitigate bypass techniques. And in my opinion, having a way to increase step by step the number of rules you add in your rule set is a great way to mitigate bypass and to increase your web application security. Okay, I'm not saying that is your silver bullet, not at all. But I think it's something which it is something which gives you a good level of security for a minimum investment of resources, of money, etc. The OWASP core rule set is used by many web application firewall vendors like Akamai, like Microsoft Azure, Google Cloud, Armor, GitLab, etc. We have 2 co-leads, Christian Follini and Walter Hope. We have almost 10 developers, including me, and we have a lot of contributors from the open source community. And this is an interesting comparison made by Fractal. In the link here, you can find a related article. the comparison shows that WAF using OWASP core rule set has a higher percentage of blocked attacks than other web application firewall that use custom rule set. Okay, before reaching the end, I would like to recommend you 3 interesting books. The first one is Mod Security Handbook by Christian Folini and Ivan Ristich. And this is a really interesting book. I have learned a lot reading this book. And it helps you to know better how mod security work, know better how a web application firewall rules works, how a web application firewall impact on performance, etc. The second one is the Web Application Defenders Cookbook by Ryan Barnett, and it gives you many ideas on how to protect your web application and how use mod security, for example, to protect better your web application. And the third one is Web Application Obfuscation by Mario Hedrich, Eduardo Alberto Villanava, Garrett Hayes, and David Lindsay. And it is a really interesting book that shows you many ways to test your web application and obfuscate your payload. So thank you very much for having me. I really appreciate if you would like to give me your feedback by scanning this QR code. If you want to keep in touch, you can reach me on Twitter, LinkedIn, and I have started an English YouTube channel in which I publish translated video from our West Security Italian channel. Thank you very much.
Okay, thank you, Andrea. I have one question. Actually, it isn't on the YouTube chat, but it is a question from one of our teammates. And the question is, how did you assemble the attacks test corpus for the WAF benchmark table? Is it something standard or generated specifically by OWASP?
Okay, the comparison I showed before is made by Fractal. It's nothing. It's not something that I do it. They have. I think that you need to read the whole article to gain all of the information on which they have create the benchmark. They basically used the category of attacks or payload and tested it against many web application firewalls, but it's not something that I does. I think you have to read the whole article to have more information about it.
Okay, thank you.